So, in the interest of time, I actually won't be able to do a step-by-step sort of like coding session where I show you guys exactly the steps. However, I'll tell you exactly what I did. So I pretty much followed the instructions for this data sheet here. But now so pretty much all you all have to do is, instead of following the one-shot and periodic mode, follow these instructions. They're very analogous, actually, with the exception of, well, obviously you're going to configure the proper mode, but everything else is the same, especially the nested vector interrupt table. And I will mention, however, though, that you have to know which pins to enable, and there should be looking for the sheet. There should be a sheet which is called the P control, and what that allows you to do is it allows you to specify, I remember what they're called. They're called CCP, so CCP 0 pins. CCP 0, if I can find them. So it turns out that timer module 0, which is the one that we're going to use for pulse width detection, for the pulse width, which is input capture edge mode timer, that's CCP 0. And then for the other one, it's CCP1. And these correspond to pins PB6 and PB7 on the TIVA microcontroller. So if you take the time to look that up, and then you follow the instructions on the data sheet as I did, I can actually make a quick run through of that. So let's see, it's essentially the same format, but you do the interrupt mask with the proper bit mask. We don't look at the sync register. There's a lot of registers you don't actually have to. For the control register, we apply for timer A, it was the falling edge, and for timer B, it was the rising edge. At least that's how I did it. And yeah, you just have to go through each register and make sure you configure it properly. My implementation, I'm going to demonstrate what the stream of execution is like. So first of all, you set the clock. You enable the edge mode timers. So those are the timers that I just described. So again, we have to enable the clock gating for timer 0. We enable GPIO port port B, because that's the CCPO pins, so input capture pins CP0 and CP1. So, and then this corresponds to pin 7, this corresponds to pin 6, and we do actually need alternate function select because we're not just using this as regular pins, we're using them for input capture. And then again, as I mentioned, P control register, and we do the same exact procedure I showed you guys previously, but we do this with the intention of setting this into capture registers where timer A is falling edge, timer B is rising edge. And so at the end of this initialization routine for enabling the edge mode timers, we don't enable interrupts yet, because first we have to trigger the signal, because it doesn't make sense otherwise, right? And timer, let's see, so now back at the higher level, we initialize the timer 1A/B, which is I already showed how to do, in master enable, which I again talked about already. We have a UART driver, but that's just to print out the stuff. It's not actually part of what we're trying to solve. And trigger signal enable, actually we didn't talk about that, but that's just to generate the signal. That's just to generate the initial signal. And so after we initialize timers 1A and 1B, we want to make sure we enable the trigger signal, because at this point the trigger timer, the one-shot periodic 10 millisecond timer, is already starting to count as soon as after this instruction. So then we're going to enable it, and it's going to be sustained up until the point where we go to the timer 1B handler, And what we do is we clear the flag, we toggle the pin, we clear, okay, so this is important right here. So these, when we clear the bottom 16 bits, because remember this is a 60-bit timer, this clears our, this is like pretty much synchronizing our clocks, and we're going to be like, okay, you know, start the clocks from 0. And we disable the interrupts right after we trigger. And then, yeah, so this is also important. We don't want to, when we're measuring for the capture of the rising and fall edge, we don't want to be interrupted, because that'll affect our clock. And then we also want to, yeah, this is actually enabling our timer 0A and 0B, which are our edge capture timers. And then finally we turn off the trigger signal, so that we're pretty much, at this point, we're listening for the echo pin. And the echo pins are going to be, well, this echo pin, it's going to be connected directly to the GPIO of PB6 and PB7, which are configured as input capture. And after that, the first handler that will happen would be timer 0B, when we have a rising edge that's measured, and we set this to true by setting it equal to 1. We acknowledge the capture flag. And then here we have a little bit of logic. So if we don't have it, if we have not measured a rising edge, we don't even measure anything at all. So now here, this is a pretty much some logic in order to synchronize everything. Our edge mode, excuse me, our edge mode timers. So we don't care to measure unless we first have measured a rising edge. And this is just very procedural. We acknowledge the timer interrupt. We disable the timer. We disable falling rising edge detection while we're trying to while we are completing this measurement. And then here, these registers contain the value of the timer at which the event happened. So for example, TBR will hold the timer value at which the previous rising edge occurred in the timer, and TAR contains the current value of the timer at which the rising edge happened, which is what caused the interrupt to begin with. And then we take the difference in these two times, and we have to end it with this flag, because if we look at this register and we read it, it says that only the bottom 16 bits contain the timing information. And this is just a distance calculation. It's the clock tick multiplied by the speed of sound by the pulse width, and this gives you the this converts into a distance in centimeters. And then so here we disable the, so we finish disabling both of the capture timers because they're not relevant, because we made one measurement, but in order for us to make another measurement we have to trigger again. So then that's why we enable the buffer timer. So this buffer timer is responsible for quote-unquote scheduling the next trigger, because after this timeout expires, well, we go to the timer handler, and guess what, here we enable the trigger signal again, and then we enable the other one-shot timer that is gonna be responsible for sustaining this signal for 10 microseconds, and at which point we go to the timer B handler, and then we start the process all over again, because here we toggle the pin so that it's off. We reset the timer values, the values inside the timer registers, and then we enable the edge mode timers, and then we're done. So now let's get ready for the final demonstration.